Good morning, all. Welcome back to the next class. Last class, we have studied about the heat capacity problems related to CP naught as well as the CP naught mix problems. So, this class, we will be continuing that heat capacity problems. Okay. So, what and all we have studied last classes. Q is equal to T1, T2, and Cp naught dt, that is directly Cp naught is given. If then mixture of gases is given, then we have studied about the Cp naught mix dt. Okay. Q is equal to T1, T2, Cp naught mix dt problem. So first we will do the continuation of that problems, and then next we will go to the next method of problems. Okay. So the next problem related to that Cp naught mixes are containing 21 mole percentage O2 and 21, no, just a second, I will put it on slideshow. 21 mole percentage O2 and 79 mole percentage N2 is to be heated from 303 Kelvin to the 423 Kelvin. So this is T1 and this is T2. Okay, calculate the heat required to be added if the airflow rate is 3 meter cube per minute. So the NTP, it is normal temperature per minute. Okay. So this is N, okay, using data below, two gases, that is O2 and N2 is been given. So here N is different. So the N value what they have given is different. That is 3 meter cube N2 NTP per minute. Usually we get it in kilomoles, okay, or kilojoules, kilomole per hour or kilomole per second. But here it is given with respect to volume. We will convert that. We will see that later. First we will write the Cp naught O2. So how will you write A plus Bt? 26.0257 plus Bt 11.7551 into 10 power minus 3 T. Then minus 2.3426 into 10 power minus 6. This minus all of you should remember, don't forget. Into T square minus 0.5623 into 10 power minus 9 T cube. Same way here, Cp naught, this is Cp naught O2, Cp naught N2 will be A plus Bt, that is 29.5909. Instead of plus, you have here minus, so minus 5.149 into 10 power minus 3t plus Ct square, so plus 13.1829 into 10 power minus 6 t square plus dt cube. So here instead of plus, here you are having 4.968 into 10 power minus 9 t cube. Okay, into 10 power minus 9 t cube. So this is what Cp naught N2 and Cp naught. So only thing here difference is the basis is 3 meter cube NTP per minute of airflow rate. Okay, so usually what is the thing is at normal temperature and pressure, 1 kilomole of gas will occupies, okay, will occupies a volume of 22.4 meter cube. Okay, at 1 kilomole at normal temperature and pressure, 1 kilomole of gas will occupies a volume of 22.4 meter cube. Okay, so now they have given 3 meter cube of volume. So by using this as a base, we have to find how much is the kilomole for 3 meter cube. So for 22.4 meter cube of volume at normal temperature and pressure, the moles is what? 1 kilomole. Therefore, for the given 3 meter cube of volume, you will be having 3 into 1 divided by 22.4. So, you will be having it as 0.134 kilomole per minute. Okay, 0.134 kilomole per minute. Okay, they have given us NTP per minute. So, this is the N directly, or you can directly, whatever the volume given, you can divide it by 22.4 also. You will get the answer directly. Okay, this is the shorter form. It is volume divided by 22.4 will give you the number of moles. So the number of moles is done. All the other things are remains the same. That is what Q is equal to N into T1, T2, Cp naught, Cp naught mix dt. So first you have to find the Cp naught mix. Okay, Cp naught mix, that is x sigma xi Cpi naught. Okay, sigma xi naught Cpi naught. Okay, then afterwards you have to find sigma xi Cpi. So Cp naught mix will be what? X O2 Cp naught O2 plus X N2 Cp naught N2. Find that, okay, and then you will get the Cp naught mix. So you people know this. So just I am giving the final answer. Okay. So what will be the final answer is Q you will be getting as 472.5 kilojoules per minute. Okay, so as I told, this will you will get it in kilojoules per minute because it is in kilomoles per minute. You have to convert it into kilojoules per second. Minute to second is by divided by 60, so you will get the answer as 7.875 kilojoules per second. That is nothing but 7.875 kilowatt. Just a second. So the Q value will be 7.875 kilowatt. So these are all the problems which are related to Cp naught mix. If there is two gases are given, okay, if there is two gases are given, so then you have to go for the Cp naught mix. So there are two sets of problems we have solved till now. That is Q is equal to N into T1 T2 Cp naught dt. Okay, that is one set of problem. That is only one gas Cp naught value will be given. Another one is Q is equal to N T1 T2 Cp naught mix dt. Okay, if there is two sets of problems are given. So here Cp naught mix is what? Cp naught mix will be in the form of sigma xi Cpi naught, sigma xi Cpi naught. Okay, so then Cp naught formula is A plus Bt plus Ct square plus dt cube. So this always in the form of B into 10 power minus 3. This is will be in the form of C into 10 power minus 6. This will be in the form of 10 power minus 9. Although in problems it will be given as positive, but you have to take it as negative only. Another one concept is N unit. Okay, if N is not given anything, you have to assume it as 1 kilomole. Then you will get the Q as 1 kilojoule. Whatever the units, you will get it as kilojoules. Suppose if it is in kilomoles per minute, you will get the answer in kilojoules per minute. You have to convert it into kilojoules per second, so that will be written as kilowatt. Same way, if it is kilomoles per hour, same you have to convert it into kilojoules per hour, and then that can be written as kilojoules per second. Then it will be written as kilojoules per kilowatt. And one more thing is, if it is given in meter cube volume, you divide this by 22.4. Whatever you are getting, you will get in kilomole, and whatever the Q you will get it, you will get in kilojoules. Okay, in kilojoules. This is all about the Cp, that is Cp naught mix and Cp. And the next concept is mean molar heat capacity of gases. Okay, and the next concept is mean molar heat capacities of gases. Okay, that is, suppose if there is two Q values are given. Okay, two Q values are given. So then two different temperature, that is three different temperatures will be there. That is T1, T2 and T0. So at that time, how are we going to find it? So two Q values as well as sometimes three different temperatures range will be given. So we cannot find it easily by means of what the polynomial equation. So in order to avoid that, we will be using the formula as like Q is equal to Q2 minus Q1, where Q is Cp naught M2 into T2 minus T1 minus Cp naught M1 into T1 minus T0. Okay, so once again I repeat, this is the next set of formulas. Okay, Q is equal to, when there is three temperature values will be given. So at that time, you have to write as Q is equal to N into Cp naught M2 into T2 minus T0 minus Cp naught M1 into T1 minus T0, where Cp naught M1 is mean molar heat capacity of gas between T1 and T0, and Cp naught M1 M2 will be the heat capacity of gas between T2 and T0. So here T0 will be this constant. Okay, so Cp naught M2 means T2 to T0, Cp naught M1 means T1 to T0. Okay, Cp naught M1 means T1 to T0. So at this case, you have to find it. So the formula here is Q is N is equal to Cp naught M2 into T2 minus T0 minus Cp naught M1 into T1 minus T0. Okay. So now for this, we will start a problem related to this. Okay. So calculate the heat needed to raise the temperature of 1 kilomole. This is N. Okay. Of ammonia from 311 Kelvin to 422 Kelvin. Okay, this is T1 and this is T2. Using the mean molar heat capacity data, they have given the data, that is Cp naught M for NH3 between 311 and 298. T1, T0, the value they have given. Cp naught M1 value they have given, and then Cp naught value of NH3 between same compound only between 422 and 298 Kelvin. This is T2 and T0. So like this they will give the values. So this is Cp naught M1 and this is what? Cp naught M2. Okay, this is Cp naught M2. So what is the formula? The same for, so how will you do? Q is equal to N into Cp naught M2 into T2 minus T1 minus Cp naught M1 into T1 minus T0. So N value is what? 1 kilomole. Cp naught M1 and Cp naught, so just to substitute 1 into 37.7063 into 422 minus 298 minus 35.8641 into 311 minus 298. That's it. Just direct values, substitute the answer. You will get it as Q value, you will get it as 4209.35 kilojoules. Okay, 4209.35 kilojoules. Simple. So they will be given the mean molar heat capacities. Okay, three temperature difference. The constant temperature will be T0 and the remaining will be T1 and T2. Lower temperature will be T1 and the higher temperature will be T1, T2. Okay, so the next problem related to this is same. They calculate the heat that must be added to 3 kilomole of heat. So this is N. Okay, of air to heat it from 298 Kelvin to 473 Kelvin using the mean molar heat capacity data for given below. So here only one mean molar heat capacity data is given. So the formula will be is Q is equal to N into C naught Pm of T minus T0. Okay, so the temperature, this is T, this is T0. If only one is given, then the formula. If there is two things, then N into Cp naught M2 into T2 minus T0 minus Cp naught M1 into T2 minus T0. But here only one is given, so you will be having Q is equal to N into Cp naught M into T minus T0. Okay, so where N is what? You don't forget to add N. N is 3 kilomoles. Okay, so now substitute the values, you will get the answer. That is Q is equal to 3 into 29.3955 into 473 minus 298. 473 minus 298. Okay, so you will be getting the answer as 15432.64 kilojoules. 15432.64 kilojoules. Direct substitution. Okay, direct substitution. So there is only one Cp naught M value they have given. They have not given other Cp naught values. Okay, and then next problem. This is an important type of problem. Okay. So listen, they have given a natural gas has the following composition on mole basis. It is CH4, C2H6N2. Okay. Then the heat added to heat 2 kilomole of gas mixtures, that is N is 2 kilomole of gas mixtures from 311 Kelvin to 533 Kelvin. This is T1 and this is T2. Okay. We have to first find the Q. Okay, heat added to heat 2 kilomole of gas mixture from 311 Kelvin to 533 Kelvin. Then the heat to be added to heat 200 kg of natural gas from 311 Kelvin to 533 Kelvin. So the heat for 200 kg of gas, first you have to find for the given data. Then instead of N, they have given this is M. You have to for 200 kg of gas, how much is the heat capacity, that is heat to be added. So now they have given, previously they have given directly Cp naught m1 and Cp naught m2. Now same way, this is Cp naught m1, okay, and this is Cp naught m2, but here you have three different gases. So not only one value, so here you are having three different values. Cp naught m one value only you are having 3, and Cp naught m2 value alone you are having 3. So first you have to find Cp naught m1 of mix. Okay, and then you have to find Cp naught m2 of mix, and then you have to find what C naught Pm values. Finally you have to find Q. So you understand the difference between the previous problem and this problem. So here they have given only one gas, Cp naught m of NH3. Okay, so directly we have substituted in this formula and we have found. Okay, but here the difference is in this problem Cp naught m of three different gases and Cp naught m of three different gases. So this we will get it as mix 2 and this we will have it as mix 1, because 311 T1 minus T0 and this is T2 minus T0. Okay, this is T2 minus T0. So this will be like what C naught Pm. So first how we should find, I will explain you. Okay. So the basis here is N, that is what 2 kilomole of natural gas. The basis here is N, that is 2 kilomole of natural gas. Okay. So first you find the XCH4, 84 percentage. So 84 by 100, that is 0.84. And then next is XC2H6, 13 percentage, that is 13 by 100 is 0.13. Then XN2, that is 3 percentage, that is 3 by 100 is 0.03. Okay, so the next is C naught Pm of mix 1, because you have water. See here you have three different gases. So now we have to find C naught Pm of mix 1. This is, we will take it as mix 1 and this we will take it as mix 2. This is mix 1 and this is mix 2. Okay, so this is then xi, okay, sigma of xi, Cp naught m. Okay, xi, Cp naught mi. That means xi 0.84 into Cp naught m of CH4. Okay, that is 36.0483 plus, okay, Xc2H6 0.13 into C2H6 value is what, 53.5240. 53.5240 plus, okay, Xn2 0.03 into this N2 value is what, 29.1317. 29.1317. So you will get the answer as 38.1126 kilojoules per kilomole Kelvin. Same way you have to find C naught Pm of mix 2. Okay, same sigma xi Cp naught mi. Okay, so that is XCH4, that will remains the same, 0.84 into this value, that is 41.7800. 41.7800 plus 0.13 into, and now this value mix 2 cup C2H6 value, that is 67.5 4954 plus x into 0.03 into, and then for this n2 value, that is 29.3578. So now you will be getting the answer as 44.7503 kilojoules per kilomole Kelvin. So now we have found, so individual CPM values, we have combined it into a mix 1 and mix 2. So now Q is equal to N into Cp naught M, okay, that is mix 2, M2 we will be having T2 minus T0 minus Cp naught M of mix 1 into T1 minus T0. So the general formula is Cp naught M 2 into, okay, the general, usually the general formula, what the basic formula is Cp naught M2 into T2 minus T1 into Cp naught M1 into T1 minus T1. That is, the values has been given directly, only one values for one gas. So here it is a mixture of gases. So now from this we have found what? Cp naught mix 1 and Cp naught mix 2, and that for same formula will be written as Q is equal to N into Cp naught mix 1 of what? Mix 2 of T2 minus T0 minus Cp naught mix 1 of T1 minus T0. Okay, so you will be getting as Q is equal to 2 into Cp naught mix 2, that is 44.7503 into 533 minus 298 minus, okay, Cp naught mix 1 38.126 into 311 minus 298. Okay, so you will be getting as 20041.72 kilojoules. This is for the first A, okay, heat added. Now for B, the basis will be what? 200 kg of natural gas. The basis will be 200 kg of natural gas. Okay, so previously it was what? Mole. So here the basis will be what? 200 kgs of natural gas. So now what we have to find is this 200 kgs, we have to convert it into moles. Okay, 200 kgs, because the formula is having only moles. So this 200 kgs, we have to convert it into moles. So how will you convert the moles is, so usually when there is a more number of molecules, so you will be having it as weight by average molecular weight, that is M average, right? N is equal to number of moles is equal to, usually number of moles is equal to weight by molecular weight. So when there is more number of gases are there, we will be calling it as number of moles is equal to weight by average molecular weight. So now first we have to, only thing here is we have to find the M average, that is XCH4, MCH4 plus three compounds like XC2H6, MC2H6 plus XN2, MN2. Okay, so XCH4 is 0.84 into 16, okay, molecular weight of CH4. Then XC2H6 is 0.13 into 30, and XN2 is 0.03 into 28, okay, is equal to 18.18. So now find the number of moles. Okay, now find the number of moles. Just a second. I think slide is not sufficient. Okay, so M average is 18.18. So you will be having moles. Okay, N is equal to a weight by average molecular weight. Weight is 200. So 18.18. You will be getting as 11 kilomole. So now same formula, that is Q is equal to N into Cp naught M of mix 2 into T2 minus T0 minus Cp naught M of mix 1 into T1 minus T0. Okay, so in only thing is this n value varies. Okay, so 44.7503 into 533 minus 290.